Okay, guys, now we're on the rationalizing one. If you have trouble with rationalizing, I did make a quick video explaining rationalizing. So on this one, I'm not going to go as in depth, all right? Let's just start. We'll do the warm-up. 6 divided by 3, 2. Radical 6 divided by radical 3. I'm sorry, radical 6 divided by radical 2. That's a radical 3. So I divide the numbers, but I just keep them in a radical. Radical 6 over 2. That's going to stay radical 6 over 2. I can't divide a radical with a non-radical. All right? Over here, I can divide two non-radicals, though. So 2 goes into 12 6 times, and I get 6 radical 6. Over here, I have 12 rad 6 over rad 2. I can divide the two rads with each other. Rad 6 divided by rad 2 is rad 3. So this is 12 rad 3. Okay. Now there's a rule that says that we can have no radicals in the denominator. This is a really big and important rule. Don't ask me why, but it is. So whenever we do have a radical, we must rationalize. And that's what this process in this example is. This is rationalizing. Also, I've got a video on it, a separate video. It's only a couple minutes long, so you could do that. Okay, so here we are. I have a rad 8 over rad 7. 8 and 7, they don't reduce. I would normally be done, except that I've got to rationalize, which means I got to get whatever's in the denominator that's in a radical out of it. The way that works is I have to give it a pair. I have to give it a buddy to break out of the radical with. So it's a rad 7, I multiply another rad 7. But I can't just multiply the denominator, I must also multiply the numerator. And now I see what happens. Radical 8 times radical 7, that's radical 56, over radical 7 times radical 7. Well, now I have a pair of 7s that can just come out. Radical 7 times radical 7, 7. And now I can do a factor tree with this 56. 56 I know I got it with 8 and 7, so 7 and 8. And 8 is 2 and 4. And 4 is another 2 and 2. So I've got a pair of 2s that can come out right there. And then I have a lone 7 and a lone 2 that cannot come out. So this means that this 56 will become a 2 radical 7 times 2, which is 14. And then it goes over 7. And now I have something without a radical in the denominator, so I am happy. Okay, let's keep going. Number 12. Again, I have a radical 7 in the denominator, and I'm not allowed to have a radical in the denominator. The 8 is not a problem. I can have non-radicals in the denominator, so I'm only going to multiply by rad 7, okay? I'm only concerned with the one that needs to get out of the radical, that needs to get out of the denominator, okay? So just rad 7. And then I can't just multiply the bottom, so I multiply the top by the same thing. And now on the top, I have 7 rad 7. And on the bottom, I have 8 times, because I've got a pair of 7s, that becomes a 7 on the outside of the radical. And so now here I am. And I actually, before I go multiplying, why don't I just go ahead and cancel those 7s out with each other? That's beautiful. I get radical 7 over 8. All right. No radicals in the denominator. I'm happy. Okay, now I have a rad 2 over a rad 6. Well, first I'm going to simplify it, because I notice that I can divide 2 and 6. That makes it hard to see. But 2 goes into 6 3 times. I'm still in a radical, no reason to leave the radical, nobody paired up. So on the top, when everything cancels, I'm left with a 1. And on the bottom, I have a radical 3. But there's a problem because I can't have a radical in the denominator. I must rationalize. So I'll multiply top and bottom by the radical that I have in the denominator. And what I'll get on top is just radical 3. And what I get on the bottom is 3. Okay? A radical times itself, that gives us a pair of 3s, so it's just 3. We've got a cool drum line going outside. Okay. Now here I am. I can reduce this. 21 is divisible by 3. That becomes a 7 in the radical. 15 is divisible by 3. That becomes a 5 in the radical. So I've reduced this down to square root of 7 over square root of 5. It's just easier to do it after you reduce. So now, radical 5 in the denominator is a problem. I rationalize it by multiplying top and bottom by whatever radical I had in the denominator. And then I've got myself a pair here. So the top is square root of 35, and the bottom is just 5. Here, no reducing can be done. The 6 is not a problem, that radical 7 is. So I'm going to multiply by it, numerator and denominator. On the top, I get square root of 21. And on the bottom, I get 6 times square root of 7, square root of 7. That's a pair of 7s, so that's just a 7. And so this is square root of 21 over 42. Square root of 5 over square root of 3. That square root of 3 is a problem. I will rationalize it, multiplying top and bottom by the radical that is in the denominator. On the top, that's square root of 15. On the bottom, I have a pair of 3s, so that's a 3. Here, 6 and 15, I can reduce that. So I multiply the 6 by 3, I get a 2 in the radical. Here I divide by 3, I get a 5 in the radical. And this answer will become the square root of 5 over 3 square root of 2. And don't forget, if it was in a radical, after you reduce, it's still in a radical. Only thing that brings you out of a radical is pairing up like that, or like that. So now we have a rad 2 on the denominator. We're not allowed to, so we're going to rationalize the denominator. And by multiplying top and bottom by rad 2, I get radical 10 over 3 times, I got a pair of 2s. And this is square root of 10 over 6. And this one, didn't we do this one? No, we did so many very similar to it. No problem. Let's do another one. A square root of 7 in the denominator, I can't have that. I will rationalize the denominator, which means I'll multiply whatever radicals in the denominator by the bottom and the top. Square root of 7 times square root of 8 is square root of 56. And then on the bottom, I have 2 times the 7 and the 7 pair up, and I get a 7 that comes out. This becomes square root of 56 over 14. Well, I'm going to check out that 56. It's a big number. It might reduce. This is a 7 times an 8, and the 8 is a 2 times a 4, and the 4 is a 2 and a 2. So I have a pair of 2s that come out. And then I have a lone 7 and a lone 2 that do not come out. The 7 times the 2 is 14. That stays in the radical. And then this is over 14, because remember, this is the fraction I was working with, and it was a 14 on the bottom. I can, however, now simplify 2 over 14. So the final answer here is square root of 14 over 7. And that's it. All right, you guys, I hope you're loving radicals. If not, there's plenty of videos that just went up today to help you, so make sure you watch them.